We discussed A-Level Mathematics Paper 6, Probability and Statistics 2 in year 2020. Each week, a sports team play one home match and one away match. In the home match, they score a goal at a constant average rate of 2.1 goals per match. When you see an average rate and the number of goals that we are looking at, this is a Poisson distribution. So the home match here follows a Poisson distribution with a mean of 2.1. In their away matches, they score goals at a constant average rate of 0.8 goals per match. So for away matches, this is a Poisson random variable with an average of 0.8. That would be the value of lambda. You may assume that goals are scored at random times and independently of one another. A week is chosen at random. Find the probability that the team score a total of 4 goals in their 2 matches. So in each week, the team plays a home match and an away match. We can always set X to be the random variable denoting the total number of goals scored each week. So let's say X is the total. If X is the total number of goals scored each week, then X is the sum of H and A, and the sum of independent normal distribution is also a Poisson distribution. The mean would be the sum of these two. So the expected value of X is 2.1 plus 0.8. We have 2.9 here. That would give you the distribution of X, which is the total number of goals scored each week. Find the probability that the team scores a total of 4 goals in a week. We find the probability that X is 4. This is just the probability of a Poisson random variable. We have e to the negative 2.9. This is lambda. 2.9 to the 4 over 4 factorial. And that should be 0.162. For part 2, find the probability that the team scores a total of 4 goals with more goals scored in the home match than in the away match. So the number of goals scored in the home match is more than the number of goals scored in the away match. We are looking at a total of 4. Then the home match could be 4 goals, the away match could be 0. Or we have the case where the home match is 3 goals and the away match is 1. And the next case would be 2 and 2, but it will not satisfy the condition that the number of goals scored in the home match is more than the number of goals scored in the away match. So forget about this thing. We need to find the probability that we need to find is that we have 4 goals scored in the home match and 0 goals scored in the away match, or we have the probability of 3 goals scored in the home match and 1 goal scored in the away match. Now, the goals scored are random and independent from one another. Then we have probability H equals 4 times probability A equals 0 because they are independent, and probability H equals 3 times probability A equals 1. So H equals 4, we have e to the negative 2.1. 2.1 to the 4 over 4 factorial times a equals 0, e to the negative 0.8, 0.8 to the 0 over 0 factorial. The second part, h equals 3, we have e to the negative 2.1, 2.1 to the 3 over 3 factorial times e to the negative 0.8, 0.8 to the 1 over 1 factorial. Anything that is raised to the 0 is a 1. 0 factorial is also a 1. Then we can compute all that and we get a value of 0.113. For part B, you are asked to use a suitable approximating distribution to find the probability that the team scores fewer than 25 goals in 10 randomly chosen weeks. We can always let y to be the total number of goals scored in 10 weeks. So this is recall that for 1 week, X follows a Poisson distribution with a mean of 2.9. So in 10 weeks, we have Y following a Poisson distribution with a mean of Y here to be 10 times 2.9, which is 29. So Y follows a Poisson distribution with a mean of 2.9. For large mean, Y can be approximated by a normal distribution. So Y here can be approximated by a normal distribution where the mean is 29 and the variance is 29 as well. We need to find the probability that Y is less than 25. In calculating that using a Poisson distribution, it's a waste of time. To find probability Y less than 25, this is probability Y less than 25 minus 0.5, which is 24.5. Remember, we are approximating a continuous distribution from a discrete distribution. We have to apply the continuity correction factor. So if it is less than 25, you just subtract 0.5 from 25. Since Y can be approximated by a normal distribution, we can standardize this. So we have 24.5 minus the mean, which is 25. Standard deviation is square root of 29. And Z follows a standard normal. We have probability Z less than negative 0.8356. We need to find this area here, negative 0.8356. So this is the area that we need to find. And this area is exactly the same as the area on the right side here, 0.8356. We can only find this area using the standard normal table. That is 0.7983. And the area that we want is 1 minus 0.7983. Yeah, 1 minus 0.7983, giving us a value of 0.2017. To three significant figures, we have 0.202. Part C justifies the use of the approximating distribution used in Part B. We can approximate, we can have a normal approximation to the Poisson under the condition that the mean of the Poisson distribution must be greater than 5. The mean of the Poisson distribution of Y So over here, the lambda that we use is 29. This is greater than 5. Therefore, we can approximate to a normal distribution.